So before we start, I can tell you what this nice little gadget here is. This is the Microsoft Translator plugin. It comes standard with PowerPoint, and you can use it, and what it does, it analyzes your PowerPoint presentation and builds up a custom lexicon. So if you say NHI, it won't say NHI, it will actually use the words NHI. And then it uses your Office tenant to talk to Azure Cognitive Services, the same cognitive services that I'm going to show you in this presentation, to scan and do real-time translation. So if you connect to IJRQX, you can listen via audio, and you can also watch on the text, and you can save the transcript of the presentation. And this is a great way to reach other audiences who have visual impairments, other languages, and also it kind of keeps your attention, because many times this thing doesn't understand my South African accent, and it will mess up. And then everyone laughs, and I go, what? Oh, just okay. It doesn't let you swear. There's a little swear filter that you know it comes on because this is a Microsoft product. Okay, can we start, cameraman? Okay, so you can get the slides, you can get some additional content, and you can follow me on Twitter. I just hit 2,000 followers today, which was awesome. And you can scan the 2D barcode. So who am I? I'm in developer relations in Microsoft, but I'm in the marketing developer relations. So I basically assist Microsoft in Middle Eastern Africa to engage with developers. And I like to throw parties for developers. That's basically the idea. So meet Rory. This is me. No, it's not really. So Rory is, well, that's kind of what I would do if I had a superpower. But I've been trying to convince everyone that I am not related to Tyrion Lannister. Even people in this conference have gone, do you know that actor? Are you that actor? Yes, of course I am. I'm definitely that actor. And I've also tried to convince people that I don't do kids' parties, or bachelorettes, or weddings, or anything that related to entertainment. So what I started doing in my speaking career is I used AI to prove that, actually. So this is Azure Cognitive Services, and you can see there, I'm proving that I'm not actually that actor. Not the best confidence, but I'm not that actor. So that's point one done. Point two, kids' parties, right? So I took a picture, and in the picture you can see it's a totally business attire, business there. There's nothing such as birthday cake there. And for some reason, this actually scans there and says that there's a woman, and there's also a bicycle and birthday cake and everything like that. But it is actually my kid's birthday. So I do birthdays, but I do my kids' birthdays. Okay, so we've got those 2 points done. What are we going to talk about today? So I flew 27 hours here, so I'm going to just, lay it on you, because I want you leaving here knowing really a few things here. One is, I'm going to give an overview of what natural language processing is. Two, I'm going to give you an overview of what machine learning is. But if you've learned machine learning, you're going to learn something new, because I didn't know machine learning when I started this presentation. And I don't like doing things where I have to read books, so I actually did a presentation to learn machine learning. We're going to do a demo. I actually coded it about 2 days ago, because I learned that Azure actually learned Sarcasm, so I got a little bit confused and a little bit stressed, so I recoded it. And then we're going to go through Sarcasm, and we're going to see if my little coded demo actually understands sarcasm. Being South African, we're not like the Bay Area that has a very giddy kind of temperament. we're very dry and serious and dark. So sarcasm to us is almost a coming of age. Then we're going to go through a conclusion. Okay, so everyone wants to give everyone else machine learning. What's the difference between machine learning and AI? AI is machine learning in a PowerPoint presentation. There really isn't anything different, though. But I've been telling everyone with a credit card, please use cloud-based machine learning. It's easy to understand. When in truth, you don't really have to understand the basics of it because you have the ability to use the cloud-based cognitive services. And you can use it now. So we have a free tier that you can use in Microsoft Azure that gives you, with the NLP services, up to 5,000 a month calls to use machine learning. So this is the machine learning as a service. And you can see there, I put in there, Text Analytics API is a cloud-based service that provides advanced natural language processing over raw text and includes 4 main functions: sentiment analysis, key phrase extraction, language detection, and entity linking. And it gives you the language, which is English, the key phrases, the sentiment, and the linked entities. And this is the basics of the text analytics that you can get with Microsoft Azure. But, so just telling you about the text analytics API isn't going to help you understand exactly what's going underneath there. And also, I think it's important to mention that a lot of these services don't necessarily have to be used just for large corporations and specifically organizations that focus on our industry. A lot of these services, and I'll touch on that also, are used to make and better the lives of you and I. And we'll touch on how you do that, though, but understand that you can use some of these services to improve the lives around you, and we'll go through that later. So I gave myself a challenge. This is sad Affleck, not too sad since he's left the DC the universe. And I gave myself a challenge to actually travel the world and speak on these services and empower everyone in every organization to do more. And like my hero, no, he's not a hero, actually. He actually turned out to be quite a villain. Let's start. So NLP. So that's the same text that we had there before. Let's break it down and see exactly what each component is. So entities. So entities are your nouns, your specific subjects that you're speaking on. In this, we've got the Text Analytics API, which is an entity. We also have key phrases. So if you remove all of the gray areas there, we've got service, language processing, raw text. Then we have language. So this is Great British, the actual language. And it's very interesting because I've asked nearly the whole conference, what language do you think they are? And apparently I'm Scottish, which is vastly different from my accent. Scottish, so every time they do that, I put on a Scottish accent and go, I came back to Scotland to raise crops and God willing a family. And they sit there and go, yeah, no, hey, that's not you. Please don't do that. I think that was a good rendition. Okay, so we also have syntax. So I went to private school, so that's a proper noun, which is, I think, different from a noun somewhere. I can't remember, actually, though. And then sentiment, the subject of this talk. So that sentiment was 79%, which is overall positive sentiment. So we've touched on machine learning as a service, which is just you chuck in text and gives you the result. But let's actually do it manually. Because once you do it manually, you'll see how it actually works. So manually, you take the weighting of each word, and you take a kind of a human-based, vetted word index that people have actually painstakingly gone down and said, that's a good word, that's a bad word. So my legs ache. Ache has a negative sentiment of -2. You're the coolest. Coolest, 3. I hate Paul, but encourage him. -4 for hate, a strong word, but encourage him too. So the weighting of the entire sentence actually is -2. So now you can kind of see that text that we had there had a score of 79% because there was some words in there that could actually have had negative sentiment. You also get some superpower words. So like superlatives. I am extremely impressed. Extra 2 points. You are the coolest. Exclamation mark, exclamation mark. More points. Punctuation adds weight. You hate me. Sad face emoji. So -2 points for that. So to give you an understanding of the complexity of this, this is the Stanford NLP tree bank. You can go there. All of these slides are available also. I'll put them up later. And this breaks down most of the IMDb movie reviews into a sentiment tree. So this movie here, it says, it's a brilliant, honest performance by Nicholson, but the film is an agonizing bore except when the fantastic Kathy Bates turns up. Anyone know the movie? It's about Schmidt. It's one of those movies that you just switch on to have in the background while you're programming because you just need something to actually keep your mind busy. But you can see there the first part of it, the blue, positive sentiment, and then it gets their agonizing bore, really bad negative sentiment. But the overall sentiment finishes off at 14% because it weighs the entire sum total of the review. You can go in onto the Stanford tree bank and you can put your own text in there and it will do the same. It will break it down into an index. So now that we've done it manually, let's look at machine learning. Every time you do a Yelp review, every time you go on Amazon, every time you send a tweet, something is analyzing the sentiment of your engagement. Wouldn't it be nice to know how? Wouldn't it be nice to know when you actually go into a chatbot and say, I will kill you if you don't give me a human being right now? And it goes, hey, sir, it's very nice that you're having a great day. So you've been using machine learning since the 80s, actually. 80s and 90s. We all have. Who here has a smartphone? Because I don't. Can someone do a GoFundMe, please? I've got an old S4, and I don't know. I'm getting too old to actually swap out there. So a smartphone has actually predictive text. And what happens if you do the word and then you change it afterwards? Or you do the same word and you change it, it learns. You've been using machine learning this entire time. Similarly, Google autocomplete. This is the cleanest autocomplete I could find, though. So yeah, please don't try and present on autocomplete. It's just a cesspit. But Google autocomplete, and Google autocomplete takes not only your text on your predictive text, but everyone's. It learns from a collective consciousness. So when I first started learning machine learning, I thought, okay, cool, we're going to create an AI. So I tried to create a pass the butter robot, a Rick and Morty pass the butter robot. And it failed dismally. So it's also kind of, I'll show you why, because it didn't really understand my South African accent. And I screamed at it, and it wouldn't actually respond differently. It didn't understand I was screaming at it. It didn't understand that my context of my emotions had changed. So let's look at exactly why. So at first, with machine learning, there's 3 main stages. You generate your example data. Usually, you need to mark that if you're doing sentiment analysis manually. Then you train a model, and then you deploy the model. So how does that work? You've got your labeled observations. You generate your data. You've got your training set and your test set. So your training data might be the IMDb movies, but your test set are what you consider to be accurate representations of your data. You put it in a machine learner, it creates a prediction model, a binary model. Then you take your test set, push it through your prediction model, and it creates statistics out of that. That's really data science. So what happened really to change it from machine learning into deep learning? So anyone here have one of those rigs where you Bitcoin mine, that you have your GPUs on top of each other, water-cooled, like those Raspberry Pis should be? I think like 10 of them actually failed halfway through that little experiment. So what happened is that the amount of data that was produced was so big we couldn't actually process it anymore. We needed another mechanism. So the big data explosion there, the gap between the available data and the data that you can actually process. That's big data. We couldn't process it anymore. So what happened was we created deep learning. Now, deep learning is a little bit of natural language processing, a little bit of machine learning, but really sits focused on machine learning. Natural language processing is an entire data science on itself and more larger than this entire talk. So keep that in mind. We know how to do massive amounts of data, and we know that we need to process text. So how do we process that in a deep learning way? So machine learning and deep learning. With deep learning, you just take the data, chuck it into your, to create your prediction model. But at the same time, you don't actually extract any of the features, sentiment, language, any of the key characteristics before you actually do the processing for the classification. You do it at the same time. And it's a very interesting, fascinating process because it's modeled on the human brain. So have you ever tried to grasp a thought? Usually I go, what did I eat last, breakfast? And you watch yourself thinking through the process, chasing memory after memory after memory. Some memories are heavier than others. It's similar to the deep learning process because you get triggered. As a memory gets triggered, it adds a weight onto the process and follows a certain process. So that's really what an artificial neural network is. You have the neurons which are fired because they have closer proximity. Now, remember the original text. We know the weightings. So we can adjust the weightings to proximities of each other. So we've got the source text there. Quick brown fox jumped over the lazy dog, and I dropped my laptop about 3 weeks ago. And the first thing I did was, quick brown fox. I said, RT, my laptop broke. And he goes, how do you know? It goes, I can't do quick brown fox on it. And then you create training samples of that, approximations of words that are close to each other. Once you have that, you create a vector. So the Lions will win the Tri-Nations. We play football, soccer, the ball that goes that way, but we actually don't wear the helmets that you can beat each other up on. We just don't wear anything, actually. So watching you guys wear like full garbed, army stuff it's pretty weird. So I took that text, you put it into the layers for your deep learning, and you come up with Markov chains, which are vectors, approximations inside a 3D plane of where the words sit. In our case, with sentiment analysis, where they would sit close to each other. You represent that in a 3D plane. So for the example there, O would be representative of a matrix of numbers. You graphically represent the word in a 3D plane. It's coming, don't worry. I see a few confused faces, but it'll hit you like a ton of bricks soon. So you've got your vector and the approximation. So king to queen, male to woman, walking to walk, swimming to swan, country to capital. And then you create your model. So in this example here, I created a model of 100 billion words from Wikipedia and mapped it into a universe. And this is an actual visual representation of what it looks like when you create your model. So I'm looking for the word million there. So I find it, we'll find it in the universe. And then we have the approximation between other words. So million is near billion, which is near dollars, which is near million. When you give your client your representation of your database or a Word document, give him a galaxy. Give him this representation. I tried to do this with NPM. It crashed my PC. So the tool that this is Word2Vec graph. We've got some time later. I'll show you the representation, and I can fly through the galaxy, and we'll have some fun. So you've got that approximation. In deep learning, we've got our document, our corpus. We pop it into our documents vector. It averages out, normalizes it. You've got your hidden layer, the different layers that you actually do your neurons firing. Your softmax layer that actually collects it. And then finally, you've got your document classes. And also, when I was learning this, I thought, that's great. Show me. Just like I created that universe there, the representation of the machine learning in a graphical. I spent some time looking for the ability to find out how can I see the neurons firing. Because this is great, but I want to see physically neurons firing based on sentiment analysis of text. Because at the same time, when you're learning sentiment, and you're learning and you're actually firing that, it feeds back into itself. So it's a constant evolutionary process. So how does this look? So this is called the LSTM neural network that the Harvard guys actually created that gives you a representation of how neurons fired. So we learned our corpus, we fed our training set, we've got our models, and in here it says for over $15, this is a guy trying to find addresses for his daughters. What can I get my daughters? So let's fire the neurons. We mouse over it there on the Harvard tool, and you'll see here, when it happens, Harvard tool. Let me see exactly. There we go. So mouse over it, and then we can see the actual neurons firing through the network. Finding that pathway through that galaxy of the exact proximity for our Markov chains. And this was a fundamental moment for me because I could understand exactly how a neural network works. So keep calm, it's demo time. So when I wanted to show this, originally I used deep learning for J, and I did a little Java demo. But I also wanted to show you how Microsoft does it. So Microsoft recently released ML.NET, the exact service, the process to create that machine learning as a service. So we're going to do that, and we're going to create a little model, and then we're going to connect to the big one in the internet, and we're going to play around with it and see if we can hack it with some sarcasm. Very optimistic. So, anyone here know Yelp? Yelp is a review process that you can actually review hotels. So in here, in Yelp, we're going to build a model. Wow, love this place. 1. So we're going to, remember, we have to human identify the sentiment of your first labeled observation. Crust is not good, 0. So these are restaurants. Not tasty, and the texture was just nasty. These are very clean reviews. I've seen some really bad reviews. So this is a Yelp review, and we're going to run this through something called AutoML. Has anyone heard what AutoML is? So AutoML is creating your machine model, but actually machine learning. So you create a machine learning, and you say, give me 30 models and tell me which is the best one. So we're going to take that Yelp model, we're going to run through machine learning for machine learning with AutoML, and we're going to create our corpus. We're going to create our actual model. So with MLNet auto-train, binary classification, so the 0 1s that we did the sentiment, dataset Yelp labeled. I'm going to tell it what the labeled index is. Number 1, which is the second one actually, has header false. Mac exploration time 20 seconds. I'm only going to give it 20 seconds to create a model. Now, if you've ever dealt with a data scientist, they'll tell you that close to 80% is enough for most of the models we use. Do you think I'm going to hit that in 20 seconds? Let's see. So the first thing it's going to do, it's going to start to actually scan the text. And it's going to go through the first iteration. And it's going to find the model, the models, and it's going to start to analyze each model by model. Then it's going to give you a comparison of the models that it found, along with the statistical analysis of why it recommends each model. Machine learning, machine learning. So if we run this, and this was 79%, which is pretty high. It's about the same level as most machine learning models. This was recently made open source by Microsoft, and this is the exact same tools and technologies that they're using for the machine learning as a service. So once we have our model, the one that we're going to use is the actual one in Microsoft Azure, then you can actually call it. Let me just show you here. So I've set up the model inside my Microsoft Azure account. So this is Microsoft Azure. And I've got a sentiment model, machine learning. And I'm using the free tier. So you can create that. I'm using my Visual Studio Enterprise because I'm not putting my credit card on the internet. Bad idea. And I'm using the free tier, which gives you 5,000 transactions for 30 days for free. You can connect to it by using the keys that it gives you. So key 1 and key 2. So I've put that into my environmental variables. And then I'm calling the REST APIs to actually get the sentiment. So this is Visual Studio Code, the best IDE created, blatant plug. And I'm getting back the rest. And then I'm converting that into JSON using JSON. Actually, a really good Google library to convert it. And the first thing I'm going to do is I'm going to just test it with some sentiment there, using English as the language and saying, I love Java. Positive sentiment? No. Somehow I get some shakes there, like, you Python people all the same, huh? So let's right-click on this. Let's see what the sentiment that comes back with I love Java. Brave man, live demoing, hey, brave.
Bearing in mind this is a Microsoft AI.
And we're all using shared Wi-Fi here. Hey, when I heard that, I was like, 96%. What about I love to hate Java? Let's play nice here, hey? Save. Okay, so I love to hate Java. So that to me, that's negative sentiment. But love and hate might have different weightings. Let's run that. %, a little bit lower. So let's actually start to dabble in some sarcasm. So I've collected some sarcasm. It's the most witty sarcasm I could find. So coming from South Africa, we recently had some electricity issues. So the top one there it's pretty interesting because it says electricity is off again, oh joy, exclamation mark, exclamation mark, exclamation mark. So let's use the first one. What do you think the sentiment's going to be? Because this is pretty sarcastic, but it's not really that maniacal. And computers don't understand dark sarcasm. So let's put it in here.
Just to clarify, the percentage is the percentage chance that it's a positive sentence?
Yes, positive sentiment. So 11%. The electricity is off. Oh, joy. Is it picking up sarcasm then? So if it is, then let's try and actually put in a very sarcastic comment. Then it should, because it's understanding sarcasm. You look good when your eyes are closed, but you look the best when my eyes are closed. Okay, so how about always remember that you're unique just like everyone else. That's pretty sarcastic. Because this should not be positive. 77%. So what happened in the beginning then? Why did it pick up that that was negative? At some point in the machine learning model that Azure is using, someone had actually linked "oh joy!" exclamation mark as negative. They had gone in there and they had changed it manually. So we've already shown that to some degree an AI can detect sarcasm, but is there a better way? Testing, 1, 2, 3. Okay, we're still on. So what is sarcasm? Until 2 years ago, I didn't actually know. I am the most sarcastic human being on the planet. And when I found it, I was going, you're being nasty to everyone, or you should actually stop though. So this is not sarcasm. This is a picture of a dilapidated house with a sign on there saying, complete home repairs. That's irony. So what is sarcasm then? This is also irony. Stop defacing stop signs. So what sarcasm is, it's actually a form of irony, except it's biting. It's a mechanism like this. Left lane ends, go ahead, pull your huge SUV in the last minute. Everyone is okay with it. But it has intention. It has intention to correct behavior. The irony doesn't. So it comes from the Greek meaning sarkasmos, which means to tear flesh, or the Sanskrit meaning a twisted utterance. But actually, its definition is a negative form of rhetoric in which natural, pleasant-sounding words are used to make harsh criticism. What do we do on the internet with it? We use it to gently tell people the actual pathway for righteousness, to correct them where we want them to go.
The current verse of that is trolling.
Yes. So over here, throwing your life away is great. You should totally keep doing that. Hashtag sarcasm. But that hashtag is important. Because without doing that hashtag, even human beings battle with sarcasm. We saw that the AI there battled with it because it didn't understand certain sentiment. American Airlines, you're doing great. Who could predict heavy travel between Thanksgiving and New Year's Eve? And bad cold weather in December, crazy. American Airlines. Kristen, we love the card words. Thank you so much.
That was probably bot answer.
American Airlines, wow, just wow, I guess I should have hashtagged sarcasm. In 2014, the Secret Service published an RFP, which I read, that wanted a computer-based annual social media analytics subscription. As part of the requirement, they wanted the AI to detect sarcasm. Because sarcasm actually can be dangerous, because if you have a threat that is mentioned online, you don't know whether the person is sarcastic or not. It's that difficult that the American government actually wanted a mechanism to do that. Because we've seen then that sarcasm isn't a 0-1 sentiment. We trained it with the Yelp reviews, and that Azure-based AI learning is actually trained on trillions, if not centillions, of actual sentiment analysis. Because it's not actually 0-1. Because human beings are more complex. So this is the emotional spectrum. And this is a take on us, actually. The most interesting part there is you'll see that boredom leads to disgust, leads to loathing. Because scientists have realized that boredom is an evolutionary trait to actually indicate that your body is sick or it's been poisoned. Have you ever wondered why children can't stop and stand still when they're bored? It's their way of actually saying, go and forage, go do something, and don't be bored. So if you are feeling bored, I saw a few of you yawned. There's some paramedics standing outside that will give you an instant shot of Netflix, and then you can come back here. But the spectrum is complicated. So how can we measure sentiment? How can we expect AI to understand sarcasm if it doesn't know emotions? Remember that hashtag? So MIT created, great example, an artificial emotional intelligence. Deep emoji. And deep emoji then was fed in 55 billion of your tweets. Some of them hashtagged sarcasm. So what I realized there is that every one of you was helping them learn. Every one of you was creating a corpus, because at the end of every one of your tweets, you were putting emojis. You were telling us the sentiment that was linked to your tweets, and it's still learning. So let's look at these tweets. So after that 55 billion, they sanitized to 1.6 billion, and they broke it up into characteristics, but we don't care about all of these emojis, we care about those ones. Most importantly, the one on the left, the I'm not impressed face, aka sarcasm. So if we know that some people have labeled sarcasm, surely then we can actually go and create a computer model in a deep neural network that actually has the output of emotions. Instead of having a 0-1, a score based up to a percentage to tell us something is being sarcastic, we can see the emotions linked to text. So the first thing that I did when I got this was I took that text there. The electricity is off again, oh joy. And it brought me back the emotional sentiment flow, indicating it was a sarcastic reply. So the electricity is off again, so zero pain face, not impressed face, I'll kill someone. The gun emoji I had to look up, it actually means really angry. Not impressed, anger. So deep emoji you can actually use in your Docker container now. MIT has released it, and it's constantly learning. So some examples here. I love mom's cooking. I love how you never reply back. That sounds like sarcasm. I love cruising with my homies. I love messing with your mind. I love how, now that you're just gone. So you go in deepemoji.mit.edu. It's got a nice mobile interface. Next time, actually, someone sends an American Airlines stuff, put it through deep emoji. So what happened? So remember what I said about accessibility? So sentiment and emotions play a pivotal role with people with accessibility issues. One of the key issues is how do you actually walk in a room and work out whether the people in the room have a happy or sad face. So we have something called Seeing AI. So it can scan text, it can see the sentiment of the text, and it can also detect the facial expressions on individuals, because you can scan the entire room and it will tell you how many rooms so how many people in the room, and then it'll give you their emotions. We also started building emotions and sentiment into our core tooling. So this is Cortana. Remember that bot that I tried to create, the pass the butter robot? And I kept on screaming in it, and it wouldn't understand what I was saying. You'll notice that Siri, Alexa, Cortana, each understand emotions right now because they have emotions teams to actually go and create that emotional sentiment flow, and not only sentiment of 1 or 0. Happy Affleck. So I've got a little bit of time, which I actually wanted to show you the flow through the galaxy. You can actually access these slides and follow me on Twitter. So at Rory Preddy, aka.ms/sarcasm. You can start on Microsoft Azure on the cognitive services. I hit like $5 this month, and I was a bit upset though. So if you're clever, you can actually get it down. And you can start in the free tier of cognitive services immediately. So let's go scan and look at some of those corpuses and see how big the NPM one is. No, you've never seen anything before like this. So let's go there. We're going to Control A. Just going to minimize that. Got it open already. So this is the galaxy here. Now the interesting thing is that you can actually fly through it. You can increase the speed. You can see it for what it is. And then you can actually go and inspect the Markov chains for individual words. Okay. That I should have actually checked. That was, yeah. Let's do something. Let's actually put the kitten. Yes. Kittens. Kittens, clever Rory. Always, never, okay. We've learned a valuable lesson. Kittens is next to puppies. Yes, puppies and kittens and everything like that. Word to vec. But what was interesting is that if I wanted to check the depreciation of a library, I would go into the NPM package there, and I want to actually go word to vec viz graph, sorry. And I would see if it has any connectivity with other libraries. 5 minutes. Okay, nearly finished, and then we can do some questions. So in here, you can actually see, and it will show you how. And then also, you can go into NPM, not that one. Let's go there. Building graph. Trying to find the NPM one. Maybe they've hidden it because it was just so terrible. Word to vec. Your own graph. I think it's that one. There we go. So let's go through NPM, and then you'll see exactly what happened there. So NPM, demo. It hasn't even done the text, but that's how big NPM is. Now, but you can see outside here that the Markov chains of certain libraries are actually dead in the water. So let's go a little bit closer. So this library over here doesn't actually exist. Asteroids game, oh, okay. And it's linked to Asteroids Fighter. Doesn't have any real claim to the core of it. So you can build this, it's pretty easy to use, word to vec graph on your libraries, on your projects, on your sentiment. So we've got a few more minutes. Let me start that slide again so you guys can actually get the slides. So questions, do we have any questions? How do I keep my boyish charm and also subscribe to a rigorous work-life balance? I don't. No, nope, don't do that. No, that's not a question. Do I have any questions? Yes, in the back.
How does the machine learning cope with data which is really random or chaotic?
Good question. I would first say that any machine learning model needs human intervention. What we've seen is that AI, left alone, erodes into something terrible. It creates bias, it creates toxic AI, and it needs humans to intervene it. A very large company was in the news recently because it had stopped actually hiring women. What had happened is that the corpus had grown to such a degree that it realized that the words woman or woman in tech wasn't a positive hire and needed to have positive intervention. So definitely, yes, you need to have that. And just like I showed you that learns the algorithm, you need to constantly learn the algorithm. So we have something called AutoML on Azure, which you can switch on, and it will constantly learn and adjust to new training sets and adjust your corpus. Did that answer your question? Okay, no more further questions. Thank you, everyone.